All right, so today what I want to do is I want to take you through a little bit of an introduction to exactly what a blockchain is and why you might want to use it. So before I actually get into the details and the nuts and the bolts and kind of showing you why we use one of these things, let's first take a look at maybe the way that we're currently doing things in our existing architecture. So if we go back and we think about the way the internet was when we first probably ever got onto it, it was all about just getting information, right? Just pulling something down from probably AOL or CompuServe or one of their servers that was hosting some information that we wanted to have access to. And then eventually, a lot of those big providers kind of just fell to the peripheries, and we discovered that we could access this data really anywhere we wanted as long as it was hosted by a reputable provider, and then we could look to that provider and trust that it came from them based on the URL or whatever their namespace was. We could kind of recognize that, and that was kind of how we eliminated a lot of the the big providers. Originally they thought that they controlled the internet, and not really. The internet is kind of very decentralized. It's what we call a mesh network. And so when we think about what we had in Web 1, it was all about consumption of information that was posted. When Facebook came around, YouTube came around, those platforms that allowed you to publish your own information, that was when we kind of turned the corner in the internet and we became our own publishers, and we call that Web 2. But that's really where we're at today. And the problem with this is that we don't have ownership of that data. The data really kind of belongs to the platform, and in many times the platform in and of itself is where the value is derived from, and maybe it's a voice, and we could be deplatformed for various reasons, and we've seen that happen in the news medias lately. So how could we maybe architect something that's a little different? How could something be created that could maybe fix some of these pain points that we're running into as far as from a platform perspective? And how could we make this better? Well, one of the things that I think that we can do is maybe not so much have platforms that are going to control your ability to communicate and do the things that are on these social media platforms, but maybe we have protocols, just a way that the standard set of rules that anyone can host these platforms in and of themselves. And I think we can probably do that with a blockchain, and there's been lots of attempts to that, but let's kind of talk our way through how we might be able to attack something as simple as that. But really what we're looking at is we're looking at the value add proposition of a blockchain and why you might want to use one. So that's really what's going to drive what I think is going to be what we call Web 3. And it's going to give you the ability to kind of have ownership of your data. And so let's go ahead and let's take a look now. What I've done here is I've given us a view of what a standard architecture might look like. And really what we're looking at here, let's put a circle, and I'll do this in blue. But really what we're looking at is we're just looking at this piece right here, right? So we're just looking at this right now, just what's inside this circle. And this is what we're used to seeing. So the front end, or what we call the web server from an IT perspective, is where the user connects to, right? They're making a connection to that machine, and that machine is responsible for giving the user, the forms that the user sees, and they fill out the form and submit or whatever it is that they are doing on that particular website. So that's the front end. And then once that data comes in, it then has to be, a decision needs to be made, right? Something has to be done with the data. So that's where the app servers come in. Right? What do I need to do with this request? How do I need to interpret it? How do I get the data from the back end? It's being requested from the user on the front end. How do I get that information? So that's where the middle tier comes into play, and it's making those decisions on what to do as far as the request is concerned. And then the back end, that's what we see here in the database section. That's going to be what we consider kind of the data store, right? And it's where we have persistent data. Now, what's happened is this persistent data set, when we think of this data set, it's a relational database management system. And it has what we call creates, reads, updates, and deletes. Now, the problem is that these updates and deletes, they cause us pain when it comes to things like governance and ownership and those types of things. So what we've been able to do in the past is we've kind of had to trust a central authority to have kind of the source of the truth for any information that needed to be held in, across the internet. So we had to kind of trust that central authority. But in a distributed manner, you can use what's called a linked list instead of a database. And that linked list is just that, a list that's linked together with another list. It's kind of like a spreadsheet on steroids, right? When you think of a ledger, let's think about a ledger for a second. It's actually called distributed ledger technology. So when you hear DLT, that's what they're talking about. But what that means is I'm going to have a ledger, credits and debits, but that ledger is going to be linked with another ledgers, right? And how are they going to be linked together? And that's what we're going to be talking about here with the blockchain. So let's go ahead and let's kind of dig. We're going to come back and we're going to look at this again in a second, or this diagram. But for right now, we're going to go ahead and minimize this. And we're going to go out here and we're going to take a look on exactly what a blockchain consists of. So when we hear this term blockchain, in order to understand it, we have to have a basic understanding of hashing. And so in the Bitcoin blockchain, we use the secure hash algorithm that's 256-bit. So if you're not sure what that means, it just means that this number down here represents a big, big number. Even though it looks like E's and F's and stuff like that, it's a base 57, I believe, number. And that number is going to have lots of different characters that can be in each one of these little spaces. And so based on that concept, there's lots of combinations, and that combinations are 256 bits. So that's how that kind of comes out. But what that means is that as you put information in, because it's called the secure hash algorithm, 256-bit. So what is this hashing algorithm that we're talking about? Well, we're putting in input. Think of what's happening in the background as the hashing algorithm. So for instance, if I just type in Tommy, you'll notice that I get this hash. And if I take out the Y, for instance, notice that the hash changes dramatically. So there's a lot of modifications that occur from the inputs to the outputs. So that's really hard for me to maybe take that output and figure out what the input was, because I can see it changes dramatically. There's no real way that I could figure that out. And then in addition to that, my inputs can be of any space or size, whereas this output that we see down here, that output is specifically of 256-bit, right? So it's a standard size output that I'm getting from the input. And so with that, I can do things like creating a hashed index, and I can do lots of fun things with this. And so we actually use this quite a bit in our blockchain. So when we come up here and we take a look at our blocks, what we're looking at is so when we take a look here at what's going on with a block in a blockchain, all it is it's just a bunch of data, right? Data that's being put into the block, and then it has a block hash. All right, so the hash is doing what? Well, the hash is telling us about the data that went into it. So it's kind of like an index of all the data that went in. Now wait a minute, there's a mining button here, and there's also this thing up here called a nonce. So let's go back and remember that each time you type in a single letter in the input, the hash changes dramatically. So if I kept typing an A, B, C, C, D, E, F. I could go ahead and I could keep trying different combinations, and hopefully I could kind of come up with things that maybe had a hash or an output that would have maybe, like, for instance, here, when we went to C, actually, E, F, A, E, D, maybe, H, there we go. So here we see that we have a leading 0, right? So notice that, you know, if I go through a bunch of combinations, maybe I'll come up and, as I just did there, I have a leading 0. Well, notice over here, we have this other thing called a nonce in conjunction with the data. Well, the nonce is going to be appended to the data as part of the data set. And in addition to that nonce, what's going to happen is you have to do what's called mining. So let's kind of understand what mining is doing. Mining is actually taking the input data, running it through lots and lots of hashes until it can find an output that meets the hardness level of the network. So for instance, in Bitcoin right now, the hash for a properly mined block, I think, has 17 leading zeros. So imagine, if you will, how hard it would be for you to come up with that number. You have to check lots and lots of numbers, and that's called a brute force attack. And in essence, that's what's happening every 10 minutes in Bitcoin. Every 10 minutes, a new block gets mined, and it's based on the hardness level of the network. So if the network mines faster than 10 minutes, then what will happen is it will go ahead and increase that hardness level so that it will take longer than 10 minutes the network longer, and make it harder. So it'll be, instead of 17 leading zeros, maybe it's 18 leading zeros. So it makes it harder, increases the hardness level. And so what mining could be thought of is, excuse me, is when we look at a blockchain, and we have all this data, and so, you know, Bill paid Sally, Bob paid John, you know, and so we have all these transactions, $60, $50, whatever, and so this would just be our ledger, right? And then we have a hash of the data that came from that ledger, but it's going to be linked. Remember, we said it's a linked list. So this would be the hash for this block after it gets mined, and notice that the hash will change because it will need to have so many leading zeros. So notice now we have 4 leading zeros here. Up here we have the nonce that was used in conjunction with the input data that allowed us to meet that hardness level, the 4 leading zeros that we talked about, of the network. And so then we would have to mine the next block. But the important thing to remember about the next block is not only does it have, you know, John paid David $50 or whatever, all the inputs of this one, but it also has something else that's being used as an input, which is the hash value of the previous block. So you'll notice here, these blocks, as they're stacked on top of each other, it creates a level of hardness for what was below it that it just can't change. I can't go back and roll back those modifications, because I not only would have to change it, but I would have to change all the blocks that are stacked on top of it. And so then not only would I have to do it on this particular node, or the node that is holding this copy of the ledger, but I'm going to be doing this in a distributed manner. So you're going to be multiple peers: peer A, peer B, peer C, peer D. And so all of these have to have the same information. You know, so when we say, you know, John paid Sally, and then we put that in, and we say $50, and we mine that, then what's going to happen is as soon as that gets mined, as soon as that block gets mined, then that peer A is going to take that data, give that data to the peers along with the nonce, and say, hey, check this out. I was able to come up with a valid block. Check it out. See if you get the same thing. why don't you do the same thing down here, Mr. Peer C? You do the same thing and check to see if what I did checks out for you as well, because I mined that. And you don't have to mine it, you just got to check my work. Well, that's what they just did, and they did check the work, and it checks out. So they're not gonna try to mine this transaction. They're gonna mine other transactions that are called in the mem pool. Right? They're gonna mine those, and then try to put those into the next block. So what this is doing is it's creating a level of contention, right? So it's kind of like a bingo game between all of these peers, where they're all kind of contending with one another. The ones that have the most hash rate are going to be able to rotate through the more nonces. And they're going to be able to mine more blocks. So when a peer, a miner in this case, has the opportunity to mine a block, then what will happen is you'll see all of these, various different transactions that have occurred, and you can mine the block and it will be distributed across, and we'll see all of the information that's maintained in this blockchain. But each one of these peers is referencing their own, each one of these nodes is referencing their own copy of the blockchain, right? So how are they validating that information? Well, they're just doing it through math, right? They're just validating that, yes, this checks out and it's good based on the hardness levels that we were talking about earlier. And so this creates a distributed network that is really kind of based on math. And in essence, that is kind of how a blockchain works. Now, let's think about that for a second. So what we just learned there when we were kind of talking about mining is we kind of learned that we were dealing with a set of data. It wasn't a database though, was it? It was more like a ledger. It was a distributed ledger, wasn't it? But that distributed ledger, it didn't just have what we would normally see in a ledger, the credits and the debits, but it also had something else. And that was this thing we've been talking about, which was the hashes. So we have hashes in the transactions, we have block hashes, we have all these hashes that are being used in order to validate the data, right? And so the hashing, the concept of all this hashing, is what kind of allows us to create an immutable data set, right? So a data set that removes, remember we talked about with the database, we have these updates and deletes. Really, we don't have those. We just have creates and reads. And the only thing you can do is make changes to the things that currently exist. And so, for instance, in Bitcoin, that is, of course, the Bitcoins, right? And those Bitcoins are simply the rewards that are given to the miners every time that they mine one of those blocks. So when they mine one of those blocks, they kind of say, bingo, and then they get paid their reward plus the mining fees. And so a lot of times that now ends up, it's at 6.25, it was at 12.5, before that it was at 25, before that it was at 50. So if you were mining on the very first Bitcoin blockchain before the first halvening, is what they call it, when they cut those rewards in half, then you would have gotten 50 Bitcoin plus whatever the mining rewards were for the block that you mined. And so you could have made like 56 Bitcoin per block, which today, that's a lot of money, a couple $1 million, right? So anyway, that's what creates the level of hardness for the network, is the size of the network and all of this hashing power that's using math to basically just say, this is the truth of what we found as far as the values and the accounting is concerned. And so that is, in essence, an immutable ledger, right? And so when we think of the database, let's kind of go back to this concept earlier. And when we think of this database, and we're not going to really necessarily store data that way anymore. A lot of times what we have to do is we have to start looking at our data set, and we have to ask ourselves which portions of this data set is structural data and which portions of this data set is contextual. And if the data portion is structural, then that piece, it can probably be what we call ephemeral. And so when it's ephemeral, it means that it's just going to go back to the state that it was in. Think your house, right? Your house had a lot of people living in it. I live in a house that was built in the 50s, right? That was before I was born. I'm an old guy, but not that old. So yeah, lots of people have lived in this house. It's the same structure, but the content, the families, the humans that have lived in there is different. Same concept here. We want to build an architecture that will allow lots of things to come through our structure, like Facebook, for instance. But the contextual data should belong to the individual that is the operator, right? The owner. And so that's kind of what we mean. We want to have the structural data that defines, how Facebook or whatever the platform it is that you're building, however it operates. And then the contextual data is the information that the user brings as part of the transaction. And so the contextual data isn't necessarily ephemeral, it's persistent. And so when we think of we want this data to persist, so when we want this data to persist, then we will go ahead and normally put it into a database somewhere. But the problem is that database, it has CRUD capabilities, right? So that update and delete causes me problems. So how can I create an immutable ledger that might be distributed where everybody's kind of just checking it through math? Voila, a blockchain. And so with the blockchain, you can kind of think of it as not necessarily what we would consider traditionally as dual entry accounting, where you have credits and debits, but it's more triple entry accounting where we're leveraging that hash in order to validate and do real-time reconciliation of the information maintained within the ledger. So let that sink in for a minute. There's a lot you can do with that, right? Real-time reconciliation of information, tracking data on an immutable data set. This solves a lot of problems that we weren't able to solve previously in computing. And there's a thing called the Byzantine general problem. I'm not going to necessarily get into that, but really what it is it's where we have a double spend problem where somebody could make a copy of a digital asset or make a copy of something and it causes that. And we run into that problem a lot when we come to digital data. But anyway, as long as the network has more compute power than any adversary, you should be able to fix this problem. And that's what this whole method that we talked about with mining. It's called the consensus method, or the method that we use to come into agreement that my copy of the ledger is in concurrence with your copy of the ledger. And so that's consensus. Okay. So that is what we're going to be looking at kind of at the back end. And so, holy cow, you mean this blockchain thing that everybody's been talking about? It's not just Bitcoin, and it's not just standard people trying to make money in finance and internet funny money and magical internet money or something. No, it's more than that, right? It's a lot more than that. It's the ability for us to kind of have a decentralized ledger and fix a lot of these problems that we were running into previously as far as computing is concerned. And so big problems are being solved here. And so when we think of this concept now and we migrate that and we say, okay, well, that's just fixing that back end problem. What's happening on the front end? What's happening on the middle tier as far as this Web 3.0 concept that you were talking about earlier? Well, as I mentioned before, the blockchain or the distributed ledger technology, the immutable ledgers, and then you can also layer smart contracts on top of that. So that's kind of the logic a lot of times that we want to use for manipulating and accessing and doing things with that data that might be on that ledger. And that's where things like Ethereum and some other various different blockchains come into play. Now, those things certainly can start to create kind of a code is law set of rules for how those state changes occur on that ledger. So with that, you also have a middle tier here in any kind of standard Web 3-tier tech, and that middle tier traditionally is going to be like where you would had those static algorithms, right? You're going to be like, okay, well, if somebody has a credit score over this, then they get the loan. If they don't, then they don't get the loan, right? That kind of thing. Well, what if we wanted to look at the conditions of the market? And we wanted to do that real time, and we wanted to look at also other things like, various different variables that were in place that were specific to that transaction time, geographic location. All those various different variables need to be in place, and it's not so much static algorithms. Well, that's where machine learning is going to come in, right? That's where, we want AI to go, but, it's not quite there yet maybe. But machine learning, we really can kind of create these inferences and say, hey, this is what I think, and this is where the data is coming from, and then just make decisions based on the conditions and start to build kind of the ability for the machine to learn on its own. Look at these conditions and make some inferences on decisions that need to be made based on that data set. So you'll see a lot of things getting disrupted at that layer too, with various different machine learning tools. In addition to that, you also have this thing called a DAG, and we'll talk a lot about that too, especially as you start to get into blockchains, because we use this in order to do things like tracking your workflow and things like that in the state of an asset. So we use these quite a bit in a blockchain and a supply chain type model. And then let's go ahead and just kind of talk about the front end piece right here. And so, when we think about this front end piece, so the front end piece is kind of alternate reality, virtual reality. That's just your screens and your thumbs problem, right? We have problems with our inputs and outputs. We can't get data in fast enough, and it can't be accurate enough because we have thumbs and screen problems. Or we can't get the data back out of the system, right? So we use things like maybe virtual reality or alternate reality to kind of infer whatever it is that we're looking for. So anyway, with all of that, so you take all of that and you wrap it all up into one, and you think, holy cow, man, this whole stack that you've been using since the internet got started, it's kind of getting disrupted. I mean, it's all getting disrupted at the same time. Yeah. You're right. And so that's why I propose these projects to you students. And so I know many of you are watching this on YouTube and you don't know what I'm talking about, but that's what I created this video for. And so for those of you students that are watching this, that's what we propose these projects to you for. We want to kind of get your wheels turning. So we have a few that I proposed to you. Let's go ahead and kind of review them real quick. One on decentralized fisheries, one in track and trace of our fish population. Pretty simple, lots of ways you can go there. One on getting more insights into our construction sites and inspections and claims that might be done, and how we might be able to use some of this tooling in order to address those problems and pain points. One on insight into voting and campaign finance and ensuring possibly ensuring campaign promises are upheld, that type of thing. Lots of different ways you can go with that in a smart contract. And then let's see, what was the last one? And then the final one was actually tracking and tracing your pets, right? So having ownership of your pet, and then all of the digital information that might be important for you to collect about that pet, and then maybe leveraging that information in various different ways as a pet owner. And so anyway, those are kind of the pitches that we're looking for this semester. And so hopefully that is something that is going to be of interest to you guys, and you can have a shot at working on one of these projects. And so I hope you enjoyed the presentation on blockchain. If you have any questions, certainly feel free to reach out to me. I'm always interested in helping students expand their knowledge. So I hope this has been beneficial to you. I hope this helps to open up your ideas, and give you some passion about this new tech, because we really are living in what we will consider the fourth industrial revolution, I believe, and we're just at the spark, right? So hopefully I can help you to kind of understand where some of this will fit in. All right, thanks, and have a great day. Take care.